Hello, my name is Adela Wangui from Kodarasa. Today I'm going to do a brief overview on domain-driven design. Welcome, and I hope you do enjoy. Let's look at domain-driven design. What is DDD? It is a software design approach by your domain. So you model it according to the domain you are creating in the first place. It is a set of tools that assist you in designing and implementing software that delivers high value both strategically and tactically. At the end of the day, we do want to connect the implementation, that is the code, to the core business concepts of the domain. And that's why we do have domain-driven design. It's driven by the domain. At the end of the day, the implementation needs to match what we have in the domain and have the same language. We use the word domain a lot. What is it? It is a specified sphere of activity or knowledge. Every software program relates to some activity or interest of its users. That's what the domain is. If you're talking about a supermarket, that's our domain. If you're talking about online shopping, that's our domain. If you're talking about shipping, that's our domain. If you're talking about, I think you get the idea. The health industry, that's the domain we're talking about. And within that domain, there's still different big parts to it. So ideally, a specified sphere, I don't know, I'm struggling to say sphere, a specified sphere of activity or knowledge. That's what we mean when we say domain. What is a model? It is a selectively simplified and consciously constructed form of knowledge. Every model represents some aspect of reality or an idea that is of interest to the user, to the client, to the people modeling it. Ideally, that's what a model is, and that's what it does. It is an interpretation of reality that abstracts the aspects relevant to solving the problem at hand and ignores any extraneous details. So we just focus on one specific, very targeted issue and remove anything that's extra. So don't put anything that feels like it's extra, it's irrelevant. Like, ask yourself, is it relevant to the user? Is it relevant to the business? Is it relevant to you? Ask yourself all these questions, and if you feel those don't fit, remove them because they shouldn't be there in the first place. The model and the implementation should shape into each other. So this is the model and the implementation in the code. Any changes to the language you use in the model, any changes to the things we've added to the model that weren't there or removed should be reflected in the code. They should always shape into each other at all times. Changes on both ends should be reflected. The model is the backbone of a language used by all team members. This is the domain experts, this is the developers. At the end of the day, the model needs to have this same language where they both speak, like the domain experts. That is, for instance, when you're talking about a restaurant, the experts could be the servers, it could be the hosts, it could be the chefs, it could be the security guard, it could be the delivery people. All these people are domain experts. It could be the restaurant manager, and the actual developers, they should be speaking about the same thing. And be aware that terms can change in different domains. For instance, when I'm talking about order in a restaurant and order when it comes to the inventory, I'm dealing with two different words here. Order at a restaurant means an order for a meal. An order when it comes to keeping track of the inventory, even at a restaurant, means a whole different thing, and you need to use different language and separate them in a way that it's clear what you're referring to in the context you're talking about at all times. So, as I mentioned, the main players are the domain experts and the developers, and I've actually mentioned some examples of domain experts in this case. How do we achieve effective design? For effective design, we should have big picture analysis versus focus on the fine details. This is the strategic design and the tactical design. So the big picture thinking, the big picture view of things, and then at the end of the day, you also need to drill down into the details, and that's what we're going to speak about next. So strategic design highlights what is strategically important to your business. It's how to divide work by the importance of its work. So again, a very overview of everything And at the end of the day, we're focused on how to best integrate as needed. What is tactical design? We've spoken about strategic design. Let's speak about tactical design. It is a focus on the fine details and how to represent them. We won't go into much details. All these details are covered. I've done a whole course on this, on the different tactical designs when it comes to entities, value objects, aggregates, strategic design, ubiquitous language, bounded context. Go look at all of this. This is just an overview that tries to go through everything and gives a short introduction to it. I'll try and attach all these videos on the description so that, I'll leave a link to the playlist so that you actually have access to it. DDD is primarily about modeling a ubiquitous language in an explicitly designed bounded context. I've mentioned two new terms here. Ubiquitous language is the language used within this model design, and then the bounded context. What goes into, like when I'm designing, I need to have this boundary that separates what goes in and what goes out, or like keeps it a tight knit in a sense that it only captures and talks about only things that are relevant to this domain. You can read more about it. For instance, when you're talking about a school management system, a student bounded context could have student subjects, student teachers, student class sessions, student attendance, student extracurricular activities. All these things are things pertaining a student, and they all go to the student bounded context. We may have other things that are pertaining a class, for instance, blackboards they have, how many chairs they have. So all these are details involved in a class, and those belong to a class-bounded context, and we should not have a situation where things from the class are spilling over to the student and vice versa. So design it in a way that it does fit and contain everything that's required and nothing more and nothing less. So what is a bounded context? I have introduced this new term. It is a semantic contextual boundary. Within the boundary, each component of the software model has a specific meaning and does specific things. Components inside the bounded context are context-specific and semantically motivated. We've now covered the bounded context. Let's now get to know what a ubiquitous language is. What is a ubiquitous language? It's the language used within a bounded context. Terms in the code are the same as terms used to talk to business experts. Remember I talked about the developers and the domain experts, that is the main players having the same language. This language is a ubiquitous language, and they should be speaking about the same language when they are referring to a specific bounded context. Of course, that will vary from different context to different context. So yeah, every bounded context has its own ubiquitous language. And I have mentioned these terms in the code are the same as terms to talk to business experts. So it doesn't matter whether this business expert does not know how to code. When they look at the code from at least an overview standpoint, they should understand what this person was referring to. I don't mean understanding the details of, this argument is equal to this or calculations made inside, but from an overall standpoint, they should understand what this person was trying to do, or at least understand what it is referring to. I don't mean learn how to code. It is used in the discussion, design, and in the code. That is the classes, the modules, the methods, the packages, the repositories, the factories, allowing a shorter feedback loop. The reality that we have the same language means that we'll have less time used to explain what each person was meaning, and then quicker implementation, quicker changes, quicker feedback loop at the end of the day, which is good for the business. It prevents the development of different languages by both parties, causing a language barrier that causes inaccuracies and misinterpretation. That can happen a lot. For instance, developers can come with their own way of doing things. We're used to calling these things, and then the business experts have a way of calling something, and until they speak about it, until they get on the same page and iron out the names and get to a common name and throw out names that don't work. You may even have this name works today, and then maybe 1 month later we found a better name and we've stopped using this because it was bringing confusion because of X and Y. Explain this, get to know why some terms didn't work out, and then also remove them and explain why they didn't work out, and then come up with, don't be afraid to just keep changing, because it will keep developing as any other language. Even a human language, it keeps evolving with time. So don't be afraid when that happens. Clearly define the meaning of each word and term used. Equally as important, also talk about the terms that didn't fit and why they didn't fit. The bounded context is internally conceptual. With time, more clarity is attained. So we start from, I'm introducing a new term here. It will start from a problem space to a solution space. It will transition from being a problem space to being your solution space. So when you're starting up, this is just a problem. We've not ironed out the details. We've not clearly defined it. It's a problem. And at the end of the day, we want to get to a solution, a model that can actually be implemented, a model that we have thoroughly discussed and agreed upon that now is ready to be implemented. What do we mean when we say your problem space? It is where you perform high-level strategic analysis and design steps within the constraints of a given project. And this is what we mean when we say solution. It's where you actually implement the solution that your problem space discussions identify as your core domain. We have introduced a new term there called codomain. I think we'll come back to it when we're dealing with subdomains. There'll always be many bounded contexts in play, the codomain and other bounded contexts. When modeling for something, of course, you won't try to model everything at once. For instance, in the school management system, I may have a working student model, so I may not need to specifically dwell on that. I want to now iron out the class part. I want to maybe iron out the food part in the school. I want to iron out activities. Or let's say we've decided student is what we are currently dealing with at this moment, is what we've identified as a core actual problem at this point. This can keep changing. I mean, if we solve for this, it doesn't make sense to put the same effort into this. Going forward, we can focus on a whole different thing and refine that, and So let's say the core domain here is something like class. If we're focusing on class, that means this is our core domain, and this is our core bounded context. It's the bounded context that we're currently focusing on, but that does not mean there's not other bounded context. The class does not exist on its own. It revolves around students, there's teachers, I'm making a circle to signify a boundary. But yeah, the core domain as other bounded context that it is related to. A subdomain, which is a term I introduced earlier, represents a single logical domain model. Ideally, one subdomain should go with one bounded context and one bounded context for every subdomain. So a one-to-one relationship ideally. When I'm modeling, like for the teacher, there's a bounded context, then the subdomain is also the teacher in this case. And for student, then student bounded context, so that's a subdomain. A subdomain is a subpart of your overall business domain. As I mentioned, a bounded context, a domain, like a subdomain doesn't live on its own, it has other parts around it. Let's talk about restaurants. That's something everyone is familiar with. The orders, reservation, the delivery, these are different components that make up a whole of the restaurant, but they are all parts of it. So these are can be considered different subdomains. They can be considered as different bounded contexts. It represents a single logical domain model. What are types of subdomains? We have a core subdomain, we have supporting subdomain, and we have generic subdomain. Let's go through them. A core subdomain is what we are actively trying to develop for at the time, at this moment. A supporting subdomain are other subdomains around it that are working together with this core subdomain. So if I'm focusing on the teacher is a core subdomain, and then the student in this case is a supporting subdomain. They need it. And then we have another term, generic subdomain. These are type of subdomain that we don't put as much. So core subdomain is where we're putting the most effort to. Supporting, we're putting it but not as much because it's not the core business strategy at the time. And then we have generic subdomain, which is also something that the core subdomain needs, but we can outsource it, or does already exist. For instance, in the school management system, you can talk about a scoring model being a generic subdomain. It already exists, or we can get what the government is providing, we can get what the curriculum is providing, so something like that. Something that is relevant but we don't need to develop or spend any effort on is generic. Now let's introduce a new term, context map. This is the integration of the different bounded contexts. I talked about there being different bounded contexts in a domain, and I've mentioned a few of those. So this is the integration. For instance, again, in the school management system, we have a student bounded context, we have a class bounded context, we have a teacher bounded context, we have activities bounded context, we have a class routine bounded context. These are all different bounded contexts that go to a school management system, and the context map is the integration of these different bounded contexts and also their relationship. That's what they're talking about. So what are some relationships between contexts? Bounded contexts, let's use this image from the Blue Book, that is Eric Evans' book. Bounded context names enter the ubiquitous language. I've mentioned that. Bounded contexts keep model unified using continuous integration. That's a whole different term. I'm not going to dwell on that. Bounded contexts assess or overview relationships using a context map. So this other part really deals with the different context maps, the different ways different bounded contexts relate with each other. I've covered all these. Please check different videos on context maps and the different context integration, like context map methods. We have context map to anti-corruption layer. It translates and insulates unilaterally with anti-corruption layer. It frees teams to go separate ways. I'm trying not to go into this so that this video is as short as possible. Context maps support multiple clients through open source service, formalized using a published language. They overlap unilaterally as conformist. They relate allied context as customer-supplier relations, customer-supplier teams, and overlap allied context through shared kernel. Tactical design. So we've covered strategic design. Let's go into tactical design. Zoom in on implementation details using DDD building blocks. This can be the domain objects, the aggregates, the lifecycle. Let's look at how to express our domain. We can express our domain in different ways. Again, we're talking about the tactical design, the fine details when dealing with DDD. One way we can do this is using entities. What is an entity? It models an individual thing with a unique identity whose state changes over time. This can be, for instance, a student. If the identity changes, it is a new entity regardless of its attributes. That is, if the unique identity changes. This is what I mean when I say this. Look at a student, for instance. A student will need to be unique in the system because there's something we need to track the identity, We need to track who this student is. I'll give an example of where we don't need to track something. But for the case of a student, we do need to track their identity. So we can give them a student registration number. So student ID 1, student ID 2. These are two different students. They may have the same name, but they're still two different people. And student 1, let's say they change the name from Pamela to Angela. This is still the same person because the identifier is still the same. And if that changes, then we're dealing with a whole different person, regardless of the attributes being the same. So even if we have a case where we have two Pamelas at student 1 and student 2, these are still two different people. We have another one called value objects. It models an immutable conceptual world defined by its attributes. This can be things like time, date, where we track date and time. We don't need to have an ID for date time really, because it would be really, really stressful to track such details. But it could also be things like addresses. We don't need to keep track of specifically this is the postal code of this, the postal code, the post office number, the town, the city. These can be treated as value objects, and as long as we have these two attributes having the same details, for instance, a postal code of 91 Maua and another postal code of 91 Maua, these two are equal. Even if they are stated differently, they're equal by virtue of the attributes being the same. Let's look at another object, services. It's an operation offered as an interface that stands alone in the model without encapsulating state. This is where we put anything that doesn't belong to, that doesn't have an identity, that things that don't go to the state ideally. It can be helper methods, it can be things that interleave different entities, or different aggregates. So those will fit better in a service because it's stateless. It should never have state. So let's look at the life cycle of a domain object. Let's start with something called the aggregate. An aggregate is a collection of domain objects bound by a root entity. They consist of entities and value objects. I mentioned two things here, that they consist of entities and value objects, and or is plural or singular, a collection of domain objects bound by a root entity. So in a student, we may put many things may belong to a student aggregate. For instance, we can have the student activities, we can have the student subjects, and these are treated as entities on their own, something like that. And we can have value objects like the student address. So all these things pertaining a student that need to be changed uniformly belong to the student aggregate. And at the end of the day, we need to give it a root entity. So in this case, it can be something like the student entity. We need to track it as a whole. I don't need to be making changes on the student aggregate here and then going somewhere to update activities. These activities belong to the student, so they need to stay in the same place. That's what I mean. So they are tracked by the root entity, which for our case is a student ID. According to what you're modeling for, feel free to pick what fits. The root entity is called the aggregate root. We are talking about the life cycle. We've introduced something called aggregates. Let's look at other parts of the life cycle. So this aggregate has a life cycle. It lives, it's created, it's updated, and it dies. A new concept, repository. What is a repository? The abstract away the retrieving of existing objects. So these aggregates that we've created, we'll need a way of retrieving them and encapsulating this retrieval. We'll use something called the repository. A repository consists of everything after creation. That is the read, the update, and the delete. Everything after creation. Another thing that is part of the life cycle, we've talked about everything after creation. Now, what about the creation part? That's where factory comes in. They abstract away the creation of aggregates. It involves creation of new objects or reconstitution of new objects. So if I'm creating something from scratch or retrieving something from the domain and reconstituting it, recreating it, that also goes to the factory. So the factory encapsulates that. Let's look at another example from the Blue Book. Domain objects and domain abstractions. Model-driven design. Isolate domain with layered architecture. We won't cover that. Express model with services. It expresses a model with entities. It expresses a model with value objects. Within the entities, they access with repositories. They maintain integrity with aggregates. They act as root of aggregates. That's the entity. Aggregates access with repositories. They encapsulate with factories. Look at all these. I've covered them individually. So if this feels confusing, feel free to look at the whole course. I've done a whole course on domain-driven design. It's really exciting and I'm really proud of it. So value objects, they encapsulate with factories and they encapsulate with aggregates. And that's it. We did a brief overview of domain-driven design. I hope that piqued your interest for you to learn more about it. Look at my course, I'd recommend it. Anyway, thank you for watching. I am Waithera Wangoi from Kodarasa. Like and subscribe. I hope you come back for more. I'm doing more courses after this, so looking forward to having you follow the journey. Thank you.